Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so question 12 says, consider the circuit diagram below. The internal resistance of the battery and any resistance in the wires can be ignored, right? Then we are given this circuit diagram here. And then what you need to understand with this connection is that if we have our current, remember current always flows from the positive terminal. That's why you always see me doing that from the one that is longer, because this one represents the positive terminal, then the shorter one, the negative terminal. So now if your current is moving like that, then the split of current begins here, right? So whenever we see a split of current, then we know we have entered the parallel branch. So that means some of the current passes through the 3R, and then that same current passes over the 2R, and then that same current again passes over the R resistor, right? So what can we say about that? That means this resistor here, R, 2R, and 3R, they're all connected in series, but then these resistors are all connected in series in a parallel branch, right? So we know whenever we face a situation like that, if we have resistors that are connected in series in a parallel branch, then what we do is we combine those resistors to form one big resistor. So always be mindful of that trend. So I have done a lot of videos on that trend, and then I need you to note that trend because it's definitely coming in your exam. They love to put your circuit diagrams in this fashion, right? So what you are seeing there is that you have the 4R, and then when you combine all those three resistors, the R, the 2R, and the 3R, they will have to give you 6R, right? So now this is how you are seeing the diagram, right? So 12.1 says calculate the value of resistor R if the total resistance of the circuit is 4.8 ohms, right? So the 4.8 ohms is coming from these two resistors in parallel, right? So remember the 6R is representing the total of the resistance of all these three here. So to calculate, we say 1 over Rp is equals to 1 over R1 plus 1 over R2. We are given that here we have 4.8, and then this here we have 1 over R1 is 4R, and then R2 will have to be 6R, right? Now when we do the math here, that's 1 over 4.8, and then this is going to give us a 5 over 12R. Right. Now at this point, if we say 4.8 multiplied by 5, that is supposed to give us 24. And then if we say 12R multiplied by 1, that's 12R. And then if we divide by 12 both sides, then our R is equal to 2 ohms, right? Okay, then that's how we were just supposed to calculate the value of R for 3 marks. Remember, if we have R as 2 ohm, this here, the 2R means it's twice the value of R. The 3R means it's 3 times the value of R. And then 4R means it's 4 times the value of R. So that means here we would have 4 ohms. And then here we would have 6 ohms. And then here we would have 8 ohms. So that's the meaning of that. And then let's proceed to 12.2 now. So in 12.2, they say calculate the reading on the voltmeter if the current through the 4 ohm resistor is 1.8 amperes. Now, if you can just allow me to show you that again, the 4R here, if we combine those three resistors in series, we get the 6R. Right? And then what are they saying here? They're saying we must calculate the reading on the voltmeter. The only voltmeter that we are seeing here is the one that is connected in parallel to the 2R, meaning it is only reading the voltage of the 2R resistor, which now we do understand because the R is 2 ohm. That means that's 4 ohms. So that voltmeter is reading the voltage of the 4 ohm resistor only, because we can see it is only connected to that resistor there. Now, how would we calculate the reading on the voltmeter if the current through the 4R resistor is 1.8 amperes? So remember, this one is the one that is actually in parallel, right? And then 1.8 amperes. And then the 4R means that we actually have 4 times 2, which is the 8 ohm resist. Now, what we would do is that we know that these ones are connected in parallel. And then what do we know about resistors in parallel? The one thing that we know about resistors in parallel is that the voltage is the same throughout. So the voltage in this resistor would have to be the same voltage in this 6R resistor here. So that means, in other words, let's start by calculating the current. The voltage. Let's start by calculating the voltage of the 4R resist. So we will say current multiplied by R, and then our current is 1.8, but then our resistance, our total resistance for the 4R resistor is 8, because we say 4 multiplied by 2. Then if we say 1.8 multiplied by 8, then we're going to end up having 14.4 volts, right? So that's 14.4 volt. Now, what's the meaning of that? We have 14.4 volts here, but then also this one must be 14.4 volts as well, right? Because remember, resistors in parallel, they have the same voltage throughout. Now, how would we find the current? Remember, we do know the current here is 1.8 amperes. But then the other thing that we know about resistors in parallel is that they will have to divide the current. So the current flowing here will not be the same current flowing here. Now, let's calculate the current flowing in the 6R resistor. So we'll say the current for the 6R, that's equals to V over R, right? So the voltage, again, it's still 14.4, but then the R this time around, that's 6 multiplied by 2, which will give us 12, right? And then multiplied by 2, because we found that R is 2. Then 14.2 divided by 12, this is giving us 1.2 amperes, right? So that means we have 1.8 here, and then we have 1.2 here amperes. So all in all, the total resistance in this circuit is 3 amperes, right? But then now we have this 1.2 amperes. This 1.2 amperes here is for the 6R resist. But then remember, the 6R resistor was made out of combining 3 resistors that were connected in series. Now we know the current in the resistors that are connected in series is the same throughout, does not change. So that means if this 6R has 1.2 amperes, what else do we know? Even if we were to split them back apart, that means this resistor here would still hold a current of 1.2 amperes. This resistor here would still hold a current of 1.2 amperes, and that resistor that would still hold a current of 1.2 amperes. So that's what it means when we say the resistors in series have the same current throughout. So now that we know that if we split it back, the current does not change. Remember, the question was, we calculate the reading on the voltmeter, which is the voltmeter. We saw that it was connected directly to the 2R. So now to calculate the voltmeter, we have the resistance 2 times R. That's 4 ohms, because that's 2 times 2. And then we have the current. Now we can calculate the what? The voltage. So by saying the voltage in the 2R will now have to be I multiplied by R. The current is 1.2. The resistance is 4. Now, if we say 1.2 multiplied by 4, that is going to give us 4.8 volts. And that becomes the reading on the voltmeter, right? So the reading on the voltmeter is 4.8 volt. And all that was for 5 months. So it was pretty worth it. Then that's how you were supposed to calculate that. Then let's proceed to 12.3. 12.3 says calculate the energy converted in resistor 4R. So which 4R? This one here, in 2 minutes. So again, we can see that our time here is given in minutes. But then one thing that we have to note when we are calculating the energy, we always have to ensure that our time is in seconds. So how do we convert minutes to seconds? You multiply by 60. So that means 2 minutes is 120 seconds, right? So we know that the formulas for energy, V multiplied by I delta time, and then we also have W is equals to V multiplied by I delta time. W is equals to V squared over R multiplied by delta time. Then W is equals to I squared multiplied by R delta time, right? Now, obviously, you have to choose the formula that would be suitable considering the information that you have. Now, the 4R, we have concluded that this is 8 ohm. And then we were told that the current that passes through there is 1.8 amperes. And then also, again, we do know the voltage is 14.4 volts. So that means we have everything on that. We have the voltage, we have the current, and then we also have the resistance, meaning we can choose any other formula there to use. So if we go with the first formula, that's W is equals to V multiplied by I multiplied by delta T. Our voltmeter is 14, or our voltage is 14.4. Then our current is 1.8. Then our delta time has to be 120, right? Now, if you multiply all of that, that's 3,110.4 joules, right? So even if you were to do the other formulas, you are supposed to get round about the same answer. If it's not exactly the same, then yeah. And that's how you were just supposed to calculate that one. So you can try with the other formulas and see if you end up with the same answer there. Okay, so the 4R resistor is replaced with an ammeter. Then 12.4 says, how will the reading on the voltmeter be influenced, right? Only increase, decrease, or stays the same. Now, remember, we are always told that the ammeter, so if we are replacing this with an ammeter, we are always told that the ammeter has negligible resistance. So that means it has very, very low resistance, right? Now, if you are to consider that, that means if we put an ammeter instead of a resistor here, what will happen with your current? When your current flows here, will flow in that direction. But then since the ammeter here with its very low resistance will be short-circuiting, meant to say, so it will be short-circuiting the circuit. That means all the current will have to flow through the ammeter. So this is a process that is known as short-circuiting, right? So we are causing all the current to flow to the ammeter here. So that means no current will be delivered to this part of the resistors here. So that means this parallel branch of the resistors will not be receiving any current, or it will be receiving very low current. So that means in that, considering the fact that our current, so according to Ohm's law, we know that current and voltage, they are directly proportional. So if all the current flows in here and then we have very low current here, that means what happens to the voltmeter reading here? The voltmeter reading will have to decrease, right? Will have to decrease. And then in explaining that, we explain this concept, we say the ammeter has very low resistance. So when they say resistance is negligible, that means it is very, very low. The ammeter has very low resistance, which means it short circuits the parallel. It short circuits the parallel branch and causes all current and causes all the current to flow through it. So in other words, that means there is no current. There is no current that will flow to the 2R resistor, right? So if there is no current that flows in the 2R resistor, according to the relationship that says current is directly proportional to voltage, that means we also will not have any potential difference in the 2R resistor, leading to a decrease in the voltmeter reading, right? So leading to a decrease in the voltmeter reading. So that's how you explain that. You explain the concept of short circuiting, whereby you say that all the current will have to flow through that ammeter that has very, very low resistance, and then now leaving this parallel branch not to receive any current. And then if there is no current passing through there, that means the voltmeter will also register a very low reading or no reading at all. So that's how you were supposed to explain that question there for just 2 marks. And then with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.